Now, okay, prime factorization. Okay, prime factorization. All right, prime factorization. Every composite number can be expressed as a product meaning multiplication problem. Okay, product means multiplication problem. Can be expressed as a product of its prime factors. Okay, that could also be prime numbers. Okay, can be called both things. Now, prime factorization, for example, if I take the number 24, okay, 24 can be prime factored because it is a composite number. Okay? There are two ways. Nope, I got to move. You got to stay up with me today. Can't get it, then you can go on the internet and get it. There are two ways to prime factor numbers. First way is factor tree. Second way is what we call inverted division. I will be doing both ways for the next couple of days. Once I get past that, I will be doing it inverted division. I do not care which way you do it. Okay, you can do it factor tree. I will show you arguments for both ways. Okay, usually factor tree works well if you're dealing with smaller numbers. Okay, well, you're in the 6th grade and you're not always going to be dealing with smaller numbers. And I'll give you an example of one here in a few minutes. Okay, but that's the two ways that you can prime factor a number. I am going to show you both ways right now. Let's do the factor tree for the number 24. I need two factors that when you multiply them together give me 24. Judah. Thank you. I'm sorry it took you so long to figure that out. 6 and 4. Okay. Now, is 6 prime? No. Is 4 prime? No. See? That's why you got to know factors, because you got to know what's prime and what's not. Okay. So I've got to factor 6 and 4 then. Give me two factors that when multiplied together gives me 6, Jacob. What? 1 times 10? Other than 1 times 6. Mario. 3 times 2. Okay, is 3 prime? Then I'm going to circle it. Is 2 prime? Okay. We've got issues because you don't know the first few prime numbers. We covered this already. It is prime. Okay, let's go back and think for a second. First few prime numbers are 2, 3, 7, 5, 11, 13, 17, 19, 23. Those are the first few prime numbers that we covered a week ago. Actually, I think it's been closer to a week and a half ago. Now, what are the factors of 4? What are 2 factors of 4, Nick? 2 times 2. Those 2 are prime. Therefore, my prime factorization of 24 is 2 times 2 times 2 times 3. Now, I must write this with exponents. So, I need to write that as 2 to the third power times 3. It is 2 to the third power because I have 1, 2, 3 2's. That's why it is 2 to the third power. And this is the prime factorization of 24. Okay, this that I have circled is your answer. That's what you have to write. Brittany?
Doesn't matter what order you put them.
I want them in numerical order. Numbers. Put them in order. Now, inverted division. We know that division looks like that. So if I invert something, I flip it over. So inverted division is that. And I stick my 24 in there. Okay? With inverted division, you must use only prime numbers. Okay? So I just said my first prime number is what? 2. So I'm going to put a 2 right there. I'm going to divide 2 into 2 goes 1 time. 2 into 4 goes 2 times. Then I'm going to draw me another little bracket. Does 2 go into 12? Okay, once again, that's why you need to know your rules for divisibility. You shouldn't have to think. You should see that's an even number. 2 goes into every even number. So you go 2. 2 goes into 12 6 times. 2 goes into 6 3 times. So once again, here's all your prime numbers right there. So 2 to the third times 3. As you can see, you come up with the exact same answer regardless of which method you use if you do the math right. Now, if you misdivide or that's not going to work. Okay? When you prime factor using inverted division, you don't stop until you get a prime number. Okay? But once again, all of these numbers out here must be prime numbers. In other words, I can't do this. I can't have that. I can't put that out there because it's not prime. If you're going to do that, you got to use the factor tree. Okay, so this would be wrong. Don't do it that way. Okay, now we're going to prime factor 16. Actually, 16 is too easy. We're going to do 625. 625. Now, this is where some of you, it'll take you a while because you insist on using the factor tree. Okay? Somebody give me 2 factors of 625 besides 1 in 625. Judah. No. Why would you even say that? What's the last digit of that number? Does 2, is 5 an even number? Then why would you say 2? Okay, it doesn't. I'm trying to get y'all to think common sense logically instead of just spurting out stuff. Okay? That's why you're supposed to know your rules for divisibility. I can tell that I'm going to have to make y'all write those 10 times each so we can memorize them. Because you don't know them. If you did, you would be able to use them. Nick?
5.
Okay. I said dos factors of 625. Uno, dos. Nikki? 5 and 125. So you were right, Nick. I just need the other one if I'm going to use the factor tree. 5 and 125. Okay? 5 is prime. So now I have to factor 125. Once again, what are 2 factors of 125? Judah, if you say 2, I'm going to throw you out the window. Thank you. 5 and 25. For those of you that may be listening on YouTube, I'm not really going to throw Judah out the window. All right, now, I have to factor 25, which is 5 and 5. Those are prime. So, my prime factorization of 625 is 5 times 5 times 5 times 5, which expressed with exponents would be what, Quade? 5 what? Nope. How many 5s do I have up there? Right. 5 to the power of 4. Okay? Now, inverted division. Inverted division on this one is going to look very similar. Okay, we start with 2. Well, I know that 2 doesn't go into 625 because it's an odd number. Rule for divisibility. I also know that 3 doesn't go into it because 6 plus 2 is 8. 8 plus 5 is 13. 3 doesn't go into that. I do know it ends in 5, so I know 5 has to go into it, and 5 is prime. So that's 125. I know that I can continue to use 5 because of that 5 right there at the end. That's 25. 5 goes into 25 5 times. Once again, there's all your prime numbers. I got 4 of them. 5 to the 4th power. Okay? As I stated, I don't care which one you use. Just find one you can actually do it and get it done. Okay? Sophia? How did I get the what? 125 into 625? 5 like this. 5 goes into 6 one time. Be 5, remainder 1. Bring down your 12. 5 into 12 goes twice. Be 10, remainder 2. Bring down your 5. 5 goes into 25. Yeah, I just divided it into the number. That's all inverted division is you're just simply dividing instead of doing it like this where you've got all this stuff below it. How I'm really doing it in my head is I'm doing this. 5 goes into 6 one time with the remainder of 1, and I put it right there. 5 goes into 12 2 times with the remainder of 2, and I put it right up there. 5 goes into 25 5 times. I do the same thing with the next one. 5 goes into 12 2 times, remainder 2. 5 goes into 25 5 times. So I'm just doing it like you would a division problem. I just do it, me personally, I just do it better that way. Because, for example, the next one we're going to do. The problem you have is this. I want you to prime factor 1,440. See? Now, when you get into numbers like this, you're going to struggle to come up with two factors. Okay? I can come up with two factors of that fairly easily. Okay? Because I'm obviously an adult and I know how to do it. Okay? But for you in 6th grade, you're going to sit there for 2 or 3 minutes trying to figure out two factors of 1440. Well, I don't have to. I just do it inverted division. I know 2 goes into it. 2 goes into it 7, 2, 0. 2 goes into 14 7 times. 2 goes into 4 2 times. 2 goes into 0 0 times. I know 2 goes into it again. 2 goes into 7 3 times. Remainder 1. 2 goes into 12 6 times. 2 goes into 0 0 times. I know 2 will go into it again. 2 goes into it 180 times. 2 goes into that 90 times. 2 goes into that 45 times. 5 goes into 45 9 times. 3 and 3. There's all your prime factors. That's 1, 2, 3, 4, 5, 2 to the 5th power, times 3 to the 2nd power, times 5. Now, the problem you have is this. Some of you still probably haven't thought of factors of 1440, and I've already done. Okay, because why? I know how to divide is the main reason. Okay, for me, division is fairly easy in the sense of simple stuff like that. I'm not having to divide 2-digit numbers. I'm not having to divide 3-digit numbers. Now, obviously, that gets harder for everybody. But for that problem, for me, it's easier to do 1440 doing inverted division. I don't have to think. It's just divide by the prime numbers. Okay? The problem is, I know my rules for divisibility, and most of you don't. Or most of you can't use them quickly. Shortcuts are there for you to make your life easier, not harder. Okay? So, I don't care which way you do it. If you want to do factor tree for the smaller numbers, do it. You want to use inverted division for the larger numbers, do it. It doesn't matter to me. Okay? Now, next. Three times 7. Okay, I want to write this expression using exponents. So how would I write that using exponents? Trinity. Times, 3 to the 2nd times 7. That's your answer. Okay? That's how you write using exponents. Let's do another one. 5 times 5 times 8 times 8. Lily Gonzalez.
5 to the 2nd power times 8 to the 2nd power.
Yes. 5 to the 2nd power times 8 to the 2nd power. Okay? Now, next set of instructions. Write each as a product of factors, then evaluate. So there's 2 steps here. So let me give an example problem. Example problem is this. 2 to the 5th times 3 to the 2nd. Okay? So I write it as a product of factors. That would be 2 times 2 times 2 times 2 times 3 times 3. This is a product of factors. Now I need to evaluate. Evaluate means I'm actually going to multiply this together. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 1, 2, 3, 4, 5, which would be 32, times 3 times 3, which is 9. So 32 times 9. Okay? 32 times 9 is 288. Okay? So that's what it means to evaluate. Get it down to its answer. Okay? So if I had 8 to the second power times 10 to the fourth power, that's 8 times 8 times 10. Okay? 8 times 8, 64. 10 times 10 times 10 times 10, 10,000. It's just one with 4 zeros after it. 64 times 10,000. 640,000. The reason that is because I have 1, 2, 3, 4 zeros. Okay, so 64, I just put 4 zeros after it, because there's no decimal involved. Okay? Your homework, 3.3, 1 through 32. Now, please do not put this off till late tonight, because it'll take you about an hour. Huh? Welcome to life. Okay, so you have 1 through 32. You can use either prime factorization or inverted division. You have to show it, yes.